Hello, today we're gonna find an equivalent resistance of this network. Okay, so we have to evaluate the resistance between points K and L. Well, so what do we see when we look at the problem? Right away we spot this 1 ohm resistor is in series with this network. What do we spot about this network? Well, all of these 4 resistors connected from the same points because the resistance of this line is 0, so you can assume that these are equivalent points. Same here, so 4 ohm resistors are parallel to each other. Here 3 ohm resistors are parallel to each other, and 2 ohm resistors and this just blank wire is parallel to each other, and all of them are in series with each other. So let's redraw this network. Well, so you have 1 ohm resistor here, 4 ohm resistors that are parallel, 3 ohm resistors that are parallel to each other, and 2 ohm and 0 ohm resistor, which is again parallel to each other. And all these 1 ohm and the network A, network B, and network C are parallel in series with each other. So let's evaluate these resistances. So since these are all they're parallel with respect to each other, we can just use a formula for parallel resistance, and for the part A we find it's 1/4 ohm added to each other 4 times because there are 4 of them. We get the resistance of this network to be 1 ohm. Same with B, 1/RB equals 1/3 ohms plus 1/3 ohms plus 1/3 ohms comes out to be 1/1 ohm. RB is 1 ohm. Okay, so what about this one? Well, so since this is 0, I mean, I really don't want to write it in this fashion because 1/0 makes no sense. So what I'm going to do, I'm going to actually simplify the formula for 2 resistors that are in parallel to each other. So if let's say we have a resistor 1 and 2 that are parallel to each other, so equivalent resistance of these 2 resistors is just going to be sum of their reciprocals. Or if you work out this fraction, we get 1/R12 equals R1 plus R2 divided by R1 times R2. Or we just invert it and we end up with this equation. Now we can just use this formula, right? So you have 2 ohms times 0 ohms divided by 2 ohms plus 0 ohms, which is 0 ohms. Okay, and it kind of makes sense because if you have a current here, current always follows the path of least resistance. All the current is going to go through here, through the 0 ohm, right? So there is no resistance. Okay, so we know the resistance of the part A is 1 ohm here, resistance of part B is 1 ohm, and resistance of part C is 0 ohms. So the total resistance between points K and L is just sum of these resistances because they're in series. So 1 ohm plus 1 ohm here plus another 1 ohm here and plus 0 ohms from here, and it works out to be 3 ohms. And that's the answer to the question. I hope this is clear to everyone. Thank you.